Okay, so we're going to go over Z-scores. Now, this is a formula to calculate a Z-score. A Z-score is, if you remember, X, just subset 1. So it just means your piece of data, subtract X bar is our mean. Okay, so if you remember that, X bar equals the mean, or the average of the data. All right, divided by S. S is our standard deviation. So we already talked about how to calculate standard deviation. So now we're at the point where we've calculated our standard deviation. Okay, so what we're going to talk about is IQ. Okay, human IQ, just to make sense of stuff. Now, the mean for human IQ, I believe, is roughly 100. Okay, so that's our X bar, is 100. That's your point scoring on an IQ test for the general population of the world. And the standard deviation is 20, I believe. So your standard deviation is 20 in this case. So what we're going to do is we're going to create a normally distributed chart. Okay, and we're going to say IQ is normally distributed among the population, which is probably a decent assumption. Okay, so when we go to do this, so we know we have our curve, and it looks something like this. Let's say it goes up, peaks there, comes down. Okay, so we have our normal distribution here. Now, right in the middle of a normal distribution curve is the mean. And what did we say the mean was?
X bar.
X bar, what is it for IQ? So this is
100.
IQ. Yeah, that's right. 100 points. Now, one standard deviation, so we'll say 1S, is how far away?
What?
How many points away is a standard deviation? How far do we say?
20.
20. So let's say we went 20 to the right. What number would we be at? 20 to the right of the mean.
70.
And we're adding it to it. So 20 plus 100, so we got
120.
120.
And then
okay, so this would be considered one standard deviation. So we're going to say 1S. Okay, but standard deviations from the mean work to the left and to the right. We talked about this last time, right? So to the left here, you have another one. If we went to the left of 100, so we took 100, subtract 20. We'd have 80. Okay, so one standard deviation both ways. And what we're going to say is this is in the positive direction and this is in the negative direction. They're still one standard deviation away from each other. Okay. Along with that, two standard deviations. So let's talk about two. Well, if we jumped another 20 up on IQ, those are people who are up to 140. And this would be plus 2 standard deviations away. Okay. And if we went 2 to the left, well, we're down to 60, which is considered a very low IQ. So negative 2, yes. And finally, 3. 3 is usually a decent cutoff when we talk about deviations from the mean. Okay, 3 would be people at 160. And then this does go on technically for a very long time. And like your professor said, anything outside of 3 or 4 is very unusual. It doesn't mean it's not part of the data, but it's unusual. And if you recall, we talked about between one standard deviation of mean is 68% of the population. So we're going to say 68% of the world's population falls between an IQ of 80 and an IQ of 120. Okay, that makes sense. Between two standard deviations is 95% of the population. So 95% of the population has an IQ higher than 60 but below 140. Okay, that makes sense. And then from our third one, that's 99% of the population. So 99% of the world's population, oh, I forgot to write this one in, this is 40, is between 40 and 160 in terms of the IQ test. Okay, so this is tests they've done on humans for years, and they've taken averages and they've figured this information out. Okay, so let's talk about how we can relate this to a Z-score. For instance, let's say you take this test, IQ, and you score 108 points. Okay, so we got 108 as a score. Okay, well, we want to figure out where you fall in the world's population. So this curve, and technically this curve continues like this. The entire area under this curve, think of the area as being 1. So 100% of the area. And that 1 as a percentage is 100. So under the curve, so area under curve is considered 1, or known as 100%. Right? That makes sense. Okay? So, from there, what we're going to figure out is where you stand. Well, 108, we can kind of estimate where 108 is going to be on this chart, right? 108 is probably around here. That's where you are. It's a little higher than the mean. This is your score. So you're going to fall there. But in terms of the world's population, what percentage of the population is below you? And we can figure out what percentage of the population is above you. And the way we do this is by figuring out the area under the curve to the left of you. Oh, that's not what I wanted to happen there. Let's do a curve. Oh, geez. I guess that might not work. Okay, forget that. Anyways, it's the area under the curve to the left, okay? So let's figure out how much of the population is to the left of you. Well, in order to do this, we have to calculate your z-score. Okay, so your score is that. Well, we know that a z-score in itself, the formula is for your z-score is your data, right, minus the mean divided by the standard deviation. Well, our data was 108. Our mean was what? 100. And our standard deviation was, how far was it from here to here? Remember?
20.
20, that's right. That's what the standard deviation was. So what this is going to be, oops, a little too much. 108 minus 100. Okay, well, that's going to give us 8 divided by 20. And we're going to figure this out as a decimal. So 8 divide 20. 0.4. Excellent. 0.4. So what you do now is you have to go onto your Z table. So you jump onto your Z table. I should have found, you know what? I'm going to find a Z-score table. Pause this for a sec. Okay. So I found the Z-score table online here. Thank you to whoever put this up. And remember, our value is 0.4, and it's positive. That's going to be important. Some Z-score tables are only half, but I think the one they've given you is negatives and positives, so this is good. So I look on my Z-score table here. Well, this is the negative range, so I got to go down to the positive range. Okay, and it turns out the positive 0.4 is right here. So what that is 0.6554. Okay, so we're going to take that information. That's where 0.4 is, 0.6554. And you found that on your Z-score table?
Yep.
Good. So remember that number for me. What was our number? 0.6.
554.
Okay, I want to think of this as a percentage. So I'm going to multiply it by 100. Just like we did with 1. Remember the area of, we said under the curve was, it's going a bit slow, was 1. We multiply it by 100 to tell us what our percentage is. Oh, don't go all the way up. There you go. Jump down again. So we multiply this by 100, we're going to get 65.54%. Okay? So if that's our percentage, what we're going to have to do here is we jump up, and what that's telling us is how much area is before us. Okay? So in other words, we have a higher score than 65.54% of the world's population. Okay? That's how much is before us. And Z-scores always tell us how much is to our left. Had this question asked us, though, well, what percent of the population is got a higher score than you? Well, that's going to make things a little different because Z-scores always tell us the amount to the left. Okay? So if I looked at that number on a Z-score and I said, oh, and you calculate the Z-score the exact same way, right? And I said, well, 65 is above me, I know that wouldn't make sense because I'm higher than the average. The average has to be right in the middle. It has to be at 50. So let's do the entire page here. Right in the middle is 50%.
Well,
So if I got 100, 50 would be better than me, 50 would be worse. But because I'm a little higher, I know that more people will have a lower score than me. So 65% have a lower score. So in order to find out to the right, zoom in one more time, I have to take 1 and subtract that amount. Okay? So what we do is we take that Z-score we found, and we go 1 subtract 0.6554. And this is the percentage of people who got a higher score than we did on the test. Okay? 1 subtract 0.6554. 3446. So 3446 or 0.34, which is what percentage?
34.
0.46. So 34% of the people who've ever taken this test scored higher than I did on the test. Okay? And that's what z-scores are. Z-scores are telling us the area under a curve.
Oh,
So we relate it because area under a curve, because a curve's slope is always changing, we use calculus to solve it. So we don't really get into that in this course. So the z-score table is set out so that it can just tell us quickly. Once we have the z-score, how much is before, how much information is after. Okay, so it's just telling us how much of something. It doesn't tell us our actual percent on the test or anything. Like remember, we had a score of 108. It doesn't mean I had 65% on the test. It just means of people who took this test, 65 were lower than me, 34 were higher than me.
Right.
So it tells you in reference to a population.
Oh, okay.
Okay? And that's what your z-scores are trying to solve.